Hello and welcome back to another episode of Math with Sohn. Today we're going to be doing some polynomial long division, which is not the best. It's okay though. Synthetic division from the previous video will definitely be more exciting and easier to do, but synthetic division has its limitations. It really doesn't do well when you're dividing anything except for an x minus a number or an x plus a number. Once you throw a 2x minus 3, synthetic division doesn't work. If you have an x squared with what you're dividing by, synthetic division really doesn't work. Or if you're dividing by x plus y, synthetic division will definitely not do too well. Okay? So we have to have a different method. The long division method will work with any problem. Most problems that you'll at least deal with Algebra 2. All right? It won't work with a few. But for anything in Algebra 2, long division will work. All right? So it is the foolproof method for anything you got. So here we go. When you're doing long division, we got 2x minus 3 on the outside of our division bar. Again, just like before, if you're missing any terms like we are here, we were missing that x squared term, you got to put in a 0 there. Minus 2x and plus 6. Now with long division, it also applies to what you're dividing by. If there was a missing term here, then we would also have to put in a 0. All right, so with long division, you always look at the first number and the first guy. So 2x goes into 2x to the third how many times? You could also think, what do I have to multiply 2x by to get to 2x to the third? And that would be a 1x squared. All right, and then after you get that number, which is what 2x times 1x squared equals 2x to the third, you distribute it to both of these. So we're multiplying 1x squared times both of these. That would make 2x to the third, no kidding, and then 1x squared times negative 3 makes negative 3x squared. With long division, I recommend 2 different colors, maybe even 3. Distribute the negative. Change the sign, add straight down. Once we do that, the first term should cancel out every single time. 2x to the third, negative 2x to the third cancels. Now we have 0 and 3x squared makes 3x squared. Bring down the next number, minus 2x. You're welcome to bring down the 6 if you want to. Not everybody does, some people do. Start the whole process over again. 2x times what would equal a 3x squared? Well, that would be a 1.5. You could also write 3 over 2, 1.5x. Multiply the 1.5 times both of these. 1.5 times 2x makes 3x squared. 1.5 times negative 3 ends up equaling, I think, 4.5. 1.5 times 3 is 4.5. So this would be a negative 4.5x. Distribute your negative. Change the sign of both of these guys. Change the sign, add straight down. First term cancels every single time if you've done it correctly. 2x, negative 2x, and 4.5x makes 2.5x. Bring down your 6, plus 6. Start the whole process over again. 2 goes into 2.5. How many times? Well, 2.5 divided by 2 ends up equaling 1.25, which I used a calculator for that. So this would be 1.25. We're also having an inclination of being about done because notice how we don't have an x term here. And we didn't have anything else after the 6 to bring down. So we multiply 1.25 times 2, you get 2.5x. 1.5 times negative 3 ends up equaling 3.75, negative 3.75. And then we distribute our negative and add straight down. Change the sign, add straight down. This cancels, and we have a 9.75. That 9.75 is going to be the remainder because we can't divide that by 2x. So this is going to be plus 9.75 divided by 2x minus 3. Okay? Now, believe it or not, this one looked on the surface like an easier problem, but it turned into a harder problem. The ones that actually look harder tend to go by quicker because you're dividing by more things. So here, we're going to do the exact same thing. We're going to have the x squared minus 1x minus 2 on the outside. And then here we got 2x to the third minus x squared plus 3x minus 3 underneath. We ask ourselves, what do we have to multiply x squared by to get to 2x to the third? And the answer to that is 2x, because 2x times x squared makes 2x to the third. We take that 2x and we distribute it to all three of these. So 2x times x squared makes 2x to the third. 2x times negative 1 makes negative 2x squared. 2x times negative 2 makes negative 4x. We distribute a negative. We add straight down. So change the sign, change the sign, change the sign, add straight down. First term will always cancel if you've done it correctly. Negative x squared and positive 2x squared, when we add down there, makes positive 1x squared. 3x and 4x makes 7x, and then we bring down the negative 3. We only got one step left because now we're getting onto a regular term. So we got 2x. Now we're going to have a regular constant, a regular number. So x squared, we have to look at that first number and think, what do we have to multiply x squared by to get to here? We're starting the whole process over. X squared times 1 makes 1x squared. Then we take the 1, we distribute it to all three terms. We get 1x squared. 1 times negative 1, negative 1x. 1 times negative 2, negative 2. Distribute your negative. Change the sign, change the sign, change the sign. Add straight down. First term always cancels. 1 and 7 makes 8x. 3, negative 3, and positive 2 makes positive 1. That, ladies and gentlemen, is your remainder. You know it's your remainder because we have nothing else to bring down, and because x squared can't divide by the x, the 8x, and because we already have our plus 1 here. So we have 8x plus 1 divided by everything. So this would be minus divided by x squared minus 1x minus 2. Okay, and that top portion is your answer. All right, next one. This next one, even though it has a funkier format, raised to the negative 1 power just means divide because it goes to the bottom of the fraction, which means divide. So here, the reason we have this problem is because we're missing a lot of terms, which also means that it probably will be quicker. So we have x squared plus 0x minus 2. You need to include that 0x as a placeholder, otherwise things sometimes will not line up. Then we have negative 3x squared plus, not squared, to the third, plus 0x squared plus 6x plus 1. Okay? X squared times what gets you x to the third? That'd be an x. And because it's a negative 3x to the third, we have to do a negative 3x here. Take that negative 3x, distribute to all three terms. Negative 3x times x squared makes negative 3x to the third. Negative 3x times 0, 0x squared. I do recommend writing the squared, even though it's nothing. I recommend writing it. Negative 3x times negative 2 makes positive 6x. Distribute your negative. Add straight down. After you distribute your negative, change the sign. Can't really change a 0. Change the sign, add straight down. We get 3x squared and negative 3x squared. That cancels. 0x squared and 0x squared, it does turn into 0, but I'm going to write it just in case. And then look here. This is also something unique. 6x and negative 6x also cancels. So this is plus 0x. And then we bring down the 1. However, this is a unique scenario because x squared times what gets 0x squared would be 0. Okay, so the very next term would be a 0, and if you multiply all the things by 0, you get 0x squared, you get 0x, and then you get plus 0 again. That means that this is the remainder. All right, and this was a one-stepper. All right, we know it's the remainder because we brought down the 1 and there was nothing else to bring down. All right, so this is the remainder, so this is going to be plus 1 divided by x squared minus 2. Okay, so that one was actually surprisingly quick. Probably a little intimidating with all the things canceling, but quick. Number 4, this is a unique problem. All right, we're going to have x plus y here on the outside. And then it's going to be difficult to see if we're missing any terms, but I'm just going to focus on the x's for right now. We got x squared, we have an x to the first, and then we have no x's. So we went from 2x, not 2x's, but x squared had 2 x's, and then x to the first has 1x, and then no x's. So I think we're okay. with the missing terms. And we could look at the y's, but when we look at the y's, we should probably look at it in reverse. Y to the fourth, y to the third, y squared. I think it's going to work. Let's see what happens. 2x squared, y squared, minus 12xy to the third, and then plus 3y to the fourth. This would be an example that in some situations may not work with long division because maybe it's just not dividable. All right, let's see what happens. We got 2x squared y squared. What do I have to multiply? Remember, it's the first term, x by, to get to that. That would be a 2 and then an x and a y squared because 2x times x gets 2x squared, and then there is no y, so that's why the y squared is there. Let's take 2x squared and multiply by the x. You get 2x squared, y squared. 2x y squared and multiply by the y, you get plus 2x squared y to the third? Oh, no, not x squared. 2x, oh man, I messed up. Ugh, I need some whiteout. I'm going to redo it underneath it. 2x squared y squared. We're multiplying the 2xy squared by the y. If you multiply by the y, you get a plus 2xy to the third because there is the 2x that didn't have anything, and then y squared times y makes y to the third. There we go. Now we distribute our negative. When we do that, we change the sign, we add straight down. First term still cancels, yippee. Negative 2xy to the third and negative 12xy to the third makes negative 14xy to the third. Then bring down our next term, plus 3y to the fourth. Start all over. What do we have to multiply x by to get to 14xy to the third? That would be a negative 14 and a y to the third. Let's see what happens when we multiply that. We got negative 14y to the third times x. That makes negative 14xy to the third. Negative 14y to the third times y makes negative 14y to the fourth. Distribute your negative. Change the sign, add straight down. First term cancels. Next term turns into 3 and 14, they're both positive, so this would be 17y to the fourth, and that is our remainder. So plus 17y to the fourth divided by the original x plus y. Okay? So that's the majority of long division, but one of the main things with long division is realizing when long division is not needed. Okay? So I have a few problems here. They're going to go quicker because not all of them will be done with long division. This first one, you see how we're dividing by a singular term? Not long division. You divide them all individually. So we're going to divide 18 x squared, x to the 12th, y to the 7th, divided by this. So 18 divided by that stuff would be 6. 12 over 3 makes x to the 9th. 7 over 2 makes y to the 5th. Then our next part, the y to the third over y squared is bigger, so this is going to be y, but everything else was smaller, so there was no, you could write 1 over 3 if you want to, and then the x to the first and x to the third would just simplify down to x squared. The last part where we have 3 over 3, you get plus 1 over 1. You do not need to write the 1 over 1. That's for you guys. X to the third had nothing to cancel, and the y squareds completely cancel, so this is all we would have left. Okay, no problem. What about number 2? Well, number 2, you could use long division. Long division will work, but synthetic division is so much faster. And as long as you're dividing by a singular x plus a number or x minus a number, it is the preferred method, by most people at least. Notice how I put in a 0 for the missing x squared. We bring down our first number, 1, multiply, negative 4, add, negative 4, multiply, 16, add, 31. Ugh. 4 times negative 31 is negative 124. Let me make sure about that one. 31 times 4 is 124. Add straight down, we get negative 127. Remember with synthetic division that these numbers are dropping by a singular exponent, and you divide your original remainder by the original x plus 4. So that's our answer there. What about number 3, though? Number 3 is actually a unique problem, but long division would be preferred because it is unlikely that you could realize that this is technically dividing by x minus 2 and x plus 2. See how x squared minus 4 can like factor? So this is going to be a unique one. We might do it 2 different times and skip number 4 altogether because number 4 is just a synthetic division. So here, we're going to use long division. We got x squared plus 0x minus 4 because maybe synthetic wouldn't work. If you have a remainder, you can't really double synthetic division. We got 1x to the 4th plus 0x to the 3rd plus 2x squared plus 0x minus 8. So this is definitely a long division. X squared times what makes x to the 4th? That'd be an x squared. X squared times x squared makes x to the 4th. X squared times 0, 0x to the 3rd. X squared times negative 4, negative 4x squared. Distribute the negative, change the sign of everything, add straight down. First part would cancel. Second part 0, so I don't need to write that. If you want to, go ahead. 2 and 4 make 6x squared. Bring down your next term, which is 0x, and I'm going to go ahead and bring down the 8 because it looked lonely. All right, so I brought down both of those. Now we start the process over again. X squared times what makes 6x squared? That would be a positive 6. 6 times all three terms makes 6x squared. Then 6 times 0 is 0x. And 6 times negative 4 makes negative 24. Distribute your negative. Add straight down. The 6x's would cancel. The zeros don't matter. Change the sign of the 24. Do not forget to do that. And you end up with a positive 16 as the remainder. So this would be plus 16 divided by the x squared minus 4. This one apparently would not have worked with synthetic division, even though I thought previously it might have. All right. Number 4, I'm going to show you a slightly different way, but you can use synthetic division. If you use synthetic division, 1, 3, negative 18, 1, negative 3, 0, 0, sorry, got thrown off, negative 18. Okay, never mind. This is the only way. Sorry for the delay there. I thought that it was factorable on the top. We get x, just x, plus 0, minus 18 over the x plus 3. And that, ladies and gentlemen, is going to do it for this episode. Until next time, stay positive, my friends, and I will see y'all later. Bye.